If you see the electrical conduction of the heart, we all know that the SA node is the pacemaker of the heart. The currents from the SA node then pass to the AV node, then they go to the S bundle, the bundle branches, then to the Purkinje fibers. The electrical activity is being generated at the SA node. It then passes to the AV node. During this, it depolarizes the atria. What do you mean by depolarization? It means that the atria will contract. Then after the electrical activity at the AV node, it then goes to the bundle branches and then to the Purkinje fibers, causing depolarization of the ventricles, which means the ventricles will contract. Then the ventricles will repolarize. They will relax. If you see, the direction of the passage of current is like this, towards downwards. This is the normal direction of passage of current. If there is any deviation in this, there could be any problem. Now let's talk about conduction velocity. Velocity means speed. Conduction velocity, speed of passage of electrical activity. We saw that electrical activity passes from SA node to AV node to bundle branches and Purkinje fibers. Now what about the speed of passage? The speed of passage of electrical activity is slowest at the AV node. It has a reason. I said the current passes from the SA node then to the AV node. In this, the atria contracts. Then from AV node to the bundle branches, the ventricles contract. If you see, the ventricles need some time to fill the blood. Only after the blood is being filled in the ventricles will contract. So, from the SA node, the current passes through the AV node, then it passes there for a while, waiting for the ventricles to fill. After the ventricles are full, the AV node fires. This causes ventricular contraction and the blood goes out. The electrical activity is fastest at the Purkinje fibers. It will help in the contraction of the ventricles. Now let's talk about the ECG waves. If you see, this is the heart and this is the direction of passage of current. If in your body, if the direction of your passage of current in your heart is in this direction, your ECG wave will look like this. You would have all seen, if the person is dead, the wave would be flat. If the person is alive, you will have these bumps and cones. Now let's see what do they mean. In the y-axis, we will plot electrical activity of the heart. If there is any electrical activity being noted, there will be these changes in the wave. Then the x-axis will be time. We have studied that as the time passes, the current will go like this. So the waves are being formed. Now let's see what do these waves mean. The first one, this first bump, this is due to atrial depolarization. The current from SA node passes to the AV node. This causes atrial depolarization. So there is this wave. Then from the AV node, I said the passage of current is slowest at the AV node. So we can see no waves here. Then after that, the waves from AV node have reached the Purkinje fibers. So we can see here ventricles have been depolarized, creating these big waves. Now then, the ventricles will repolarize. If you see here, all the waves are moving upwards. It means positive deflection. Some waves we can see are going downwards, that is negative deflection. As I told, this is the normal way or normal side in which the current passes in your heart, normal direction in which current passes. If In your heart, if the current passes in this direction, the waves would go upwards. If the current passes in opposite direction, the waves can go downwards. This is why there is difference in these waves. Then this atrial depolarization is being given the name as P wave. Ventricular depolarization QRS. Ventricular repolarization is T wave. The atrial repolarization is being hidden in ventricular depolarization. Normally it's atrial depolarization, atrial repolarization, then ventricular depolarization, ventricular repolarization. But the atrial repolarization is hidden in ventricular depolarization. This wave, being very large, hides the small wave. Just to make things complicated, we'll form some intervals. If you see here, this interval starts at P and ends just before the QRS. This is PR interval. Then another duration, QRS. We'll see about the QRS duration. Then another interval starting from Q and ending after the T. This is QT interval. This small bump, can be U wave. It can be seen normally or in some other pathologies.